Welcome to another exciting edition of me, Mr. Wagner, talking about to you, Algebra 2 student, about math and graphing of polynomial functions. Let's do this. 6.8, analyzing graphs of polynomial functions. We will be able to graph polynomials. Now, luckily, we're going to do this in factored form. This polynomial, I'm looking at it right here, but all the polynomials will be graphing in factored form, which is great news when you're trying to find x-intercepts, your zeros, your solutions, because you're already factored. We could jump straight to ZPP. I can see these zeros. We'll be graphing in factored form throughout this unit, so it's trying to expedite the process. But take out a pen and a pad, write this down, hit pause, write it down, and come back. All right, now we're back. Steps are find your x, plot your x-intercepts. This is ZPP time because we're already in factored form. Find and plot your y-intercept. You plug in f at 0 to do this. Create a table for all your values in between your intercepts. That's your x over y. Use the degree and lead coefficient of your polynomial to find the end behavior. Use this chart, which I'll go over once we find this. Then connect your dots. Let's get ready to rock. So, graph this polynomial, x minus 1 times x plus 1 times x minus 3. Want to find what x-intercepts? We're just using ZBP. Set all three of those equal to 0. Your x-intercepts are at 1, -1, and +3. Notice this is a +1 because we added both sides. This is a -1 because I subtract that 1 from both sides. And this is a +3, just like that. So, bottom. I'm going to use my red marker because I can. 1, -1, and 3. Boom. Now your y-intercept, you just plug in f at 0. Right? Substitute 0 in for x, which would look like 1 times 0 plus 1 times 0 minus 3. Just like that. 0 minus 1 is -1. 0 plus 1 is 1. 0 minus 3 is -3. Make sure these are multiplying. -1 times 1 times -3 equals 3. +3. That's your y-intercept, so that's along the y-axis. Very nice. We move on. The table for this that you're going to want to construct, right? These are my points. I need values in between my intercepts. So from here and from here, I have to find out what's happening, and to the left of here. Right? When I'm plotting and graphing my polynomial, you have to know where it is. So those values I'm going to put in, right? I already have -1. I already have 0 because I did f at 0. There's 1, 2. I already have 3. And when we're plotting these, go 1 to the left and 1 to the right of your intercepts. So notice -1, 1, and 3. These are my x-intercepts. I already found these. We already know those. Those are points already on my graph. You have to have those. You already have my y-intercept, 0, 3, because we plugged in f at 0. The only points I'm finding now are 1 to the left, 1 to the right, and everything in the middle. Are we ready? Plug all those values in. F of -2 is equal to -2 minus 1, -2 plus 1, -2 minus 3. -2 minus 1 is -3, -2 plus 1 is -1, and -2 minus 3 is -5. A negative times a negative times a negative is a negative, and 3 times 5 times 1 is -15. Boom, that goes right there. -2, -15, and that's going to go all the way south of my graph. See how fast these things grow? These things grow incredibly fast. Right, and this is -2, boom, all the way down to -3. Just like that. From there, plug in 2 as well. That's what we got to plug in. F at 2 is equal to 2 minus 1, 2 plus 1, and 2 minus 3. Oh, don't want to do that. 2 minus 1 is 1. 2 plus 1 is 3. And 2 minus 3 is negative 1. 1 times 3 times negative 3 equals negative 3. Plot it. 2 comma negative 3. Right there. And lastly, f at 4. I'm going to compute this over here. F at 4 is equal to 4 minus 1, 4 plus 1, and 4 minus 3. 4 minus 1 is 3, 4 plus 1 is 5, 4 minus 3 is 1. 3 times 5 times 1 equals 15. Boom, there is my completed table. Totally nice. Notice how fast this thing grows. So this is what's going on. These are my points. Boom, 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 boom. And when we're drawing these, we have to connect these dots. We don't know how it's going to work out. What you have to do is you need to let this number 4 right here use the degree and lead coefficient of your polynomial to find the end behavior. This is huge. You have to do this. And this is what we look at. You compare the degree with your lead coefficient. This tells you how it's going. If I look at my function, it's in factored form. Usually, if it's in standard form, it's really easy to identify. Right? If I gave you this function, 2x third minus 5x squared plus 2x minus 3, it's really easy to find the degree. The degree is 3, and the lead coefficient would be 2. When you're in factored form, it looks a little bit different. Right? Because we're multiplying these all together. It's this times this times this. Right? Notice my degree is not 1. This is a cubic. If you multiply all those together, you will get a cubic function. My degree is 3 because when you're in factored form, you add the degrees. Because we're multiplying here, that's why we add. We do not add these degrees because we're subtracting it or adding it. Right, that doesn't change the degree. Multiplication changes the degree, addition does not. So my degree is 3. My lead coefficient for this, it's always, 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 I'm going to highlight this for you, highlight in purple. It's the value in factored form that's right there. This is your lead coefficient, which when it's not there, it's just 1, which is a positive number. So we look at my, down here, my degree is 3. My lead coefficient is 1. And when we're comparing, what you're looking for is whether or not the lead coefficient is positive or negative. And since it's 1, it's positive. My degree is 3, which means it's an odd number. A positive odd function is down and up. That's how you would describe it. It starts down and goes up. And when you draw, you have to start down, which makes sense. Start down here. Ooh. Start down. When you're connecting your dots, go very slowly. You only cross at the x-intercept. You curve around right about my y-intercept, come back down, hit that, go back up, just like this. Always go left to right, never back over itself. Don't ever go like this. Don't go like this. No, 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 no. Don't make up x-intercepts. Right? If you're going around over here, you're doing it wrong. Right? This is not an x-intercept. Don't do that. It's difficult to actually do this, but I think it's really fun. Always go move left to right. Never stop and never pick up your pen. Boom. Voila. I'll do another one. Here, this is my function. Notice 1/8 is my lead coefficient. These are my intercepts. Once again, my x-intercepts are at x equals -1, 1, and positive 3. We just did this. Basically, I'll throw this up on the graph to show the difference. X plus 1, x minus 1, x minus 3. I'm going to graph this. This is my function. It's cubic. It starts down, goes high because of my end behavior. There's my zeros. There's my y-intercept. Very nice. When I make it 1/8 of itself, notice how it kind of slows down. It doesn't grow as fast. Like these humps are much lower. It changes your y-intercept, does not change your zeros. It grows 1/8 as fast as your standard polynomial. Very nice. I move on. This function, 1/5 of x minus 3 quantity squared times x plus 1 quantity squared. Now notice these zeros are being squared, which means the zeros stay the same, but they have a multiplicity of 2. Ooh, let's go a little bit finer. Your multiplicity of 2, which all that means is it will bounce off the x-axis. It does not cross it. It bounces like a basketball on the pavement. Y-intercept is f at 0. Plug in 0 for x. 0 minus 3 squared. 0 plus 1 squared. 1/5 of 0 minus 3 is negative 3. 0 plus 1 is 1. Negative 3 squared is 9. And 1 squared is 1. This is equal to 9/5, which is just less than 2. So we're ready to compute our table. Note, start at your very leftmost 0, which is negative 1. Go 1 left of it. Right, negative 1 is my leftmost 0. I'm going to go to negative 2 and count my ways over. 0. Why is it doing this? Recreate this table. Negative 1 is my farthest to 0. I'm going to go for the negative 2. I'm going to go over to 0, which is 0, 9/5. I don't know why it's doing this. Someone please help. 1, 2, 3 is my other 0, and then 1 over to 4. Always start your framework at your zeros and go 1 to the left, 1 to the right. That's how we generate. And find these points, f at negative 2, f at 1 and 2, and f at 4. F at negative 2 is equivalent to 1/5 of negative 2 minus 3 squared, and negative 2 plus 1 squared. Negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1. Both these are squared. This becomes 1/5 of negative 5 squared, which is 25. Negative 1 squared, which is 1. 1/5 of 25 equals 5. Boom. Same thing we're going to do, but at 1. F at 1. One minus 3 is negative 2. 1 plus 1 is 2. Negative 2 squared is 4. 2 squared is 4. 4 by 4 divided by 5 is 16/5, which is about just over 3. Continue on. F at 2. I'm going to erase these and put them. 2 minus 3 is negative 1. 2 plus 1 is 3. Negative 1 squared is 1. 3 squared is 9. This equals 9/5. We are almost there. Lastly, we're going to do 4. F4, which will give us the same output. You'll notice most of these, they're not all symmetric, but they are commonly. 4 minus 3 is 1. 4 plus 1 is 5. 1 squared is 1. 5 squared is 25. 1/5 of 25 is 5. They're not always going to be this symmetric, but because this is an even function, it actually outputs it just like that. Plot your points, -2, 5, 1, 2, 3, 4, 5, -1, 0, 0, almost 2, 1, just over 3, 2, almost 2, a little bit thicker. 3, 0, 4, 5. Boom. There's my graph. End behavior. My lead coefficient is 1/5. My degree is going to be 4 because it's a square term times a square term. You add those together, 2 and 2 gives you 4, which means degree of 4, lead coefficient of 1/5 means my lead coefficient is positive, my degree is even, which means this is an up and up end behavior. Up and up looks like this. Just match them up. We're going down, down, bounce at these zeros because of that multiplicity of 2. Bounce again. Does not go through it. There will be no negative outputs for this. Thank you very much and have a great day.